So this is perhaps not, how can I say this in a nice way, not the most useful talk of the conference, I have to admit that. But it comes forth out of a few things that I've been playing with, both hobby hacky projects like my Raspberry Pi at home. I like OpenStreetMap stuff. Lots of calculations are done with distance and things like that. And I also like playing computer games, but I only really play one that's called Kerbal Space Program. So if you have never heard of this, by the end of this presentation, you would want to play with us, I think. So well, here we go. So I have to introduce you Jebediah. He is the Uber space person that is flying around with us. The color green that he uses is badass spelled in CSS, so that explains a lot. And he's always very happy. Here, landed on the moon. So the whole game works on a fictional solar system. So their main planet, Kerbin, which is equivalent to Earth, except it's a bit smaller, about a tenth of the size, has 2 moons. So you can see the orbits are a bit different, right? This one is in the same plane, whereas the other one is quite tilted, which makes it more difficult to get to. Similar moon, just like we have here. They also have one that looks green, and apparently it's made out of mint candy. So this is the one we're going to have a few exercises with later when we get to some equations. But first, some other planets, and if I have the time, I will actually end up getting to the Mars variant called Duna. Anyway, so Jebediah, he lives somewhere on Kerbin, and he lives at 4711 south, as well as 4574 degrees east, right? However, I was trying to figure out how far it is between where he lives and where the space center is. But the coordinates of the space center are given with like degrees, minutes, and seconds, right? And this is something you need to convert. So that's the first thing, because I want to know how far he has to walk to get to work, basically, right? So yeah, the coordinates with minutes and seconds is not something that many algorithms can do anything about. So a while ago, as part of a totally different thing, I wrote some algorithms in an extension that does lots of calculations with distances and stuff. And as part of that, I needed like this function that converts this. It is not the most complicated function, to be fair. But yeah, so some of the things that I will be talking about has to do with extension that I've written or I've contributed to or I've been hacking on and never seen the light of day yet because it's definitely not finished, they're really ugly. The first one is PHP Geospatial. I started that, I think, 2 or 3 years ago here with Marcus Deglos and Michael McLean, if you know them. However, they haven't been contributing lots to it, but I have. So I've sort of taken it over and changed all the APIs. So they must love me for that. And then there's something else I've been working on, PHP Solar System, which is maybe not the most useful extension, but I like playing with this kind of stuff, right? And I actually had a use for it as well, because about 3 years ago, I got a Raspberry Pi, or 2 years, I don't know how old those things are, and I want to do something useful with that. Now, I don't do hardware hackery stuff at all, because soldering irons make just my hands burn every time I touch them, and I shouldn't. So I want to do something software-wise with it. But I saw that at work, actually, they had used a Raspberry Pi stuck behind a TV to have like a support, well, what's going on support at that moment, right? So I don't have a big TV, but I have like an LCD screen that now has the Raspberry Pi connected to it. One thing I want to do in there was show the current weather. And current weather, there's lots of APIs for that, so I'm not talking about that now, but one of the things I thought would be nice was to show the background of where the weather shows should imitate the color of the sky outside. Right? How useful this is, I don't know, but I thought this was a fun project to do. And in order to do that, you actually need to think about a few things, like you need to know the current weather and how high the sun is up and stuff like that, and that's what this extension helps me with now. Anyway, let's go back to Jebediah that needs to get to work. And so yeah, there's function in the PHP Geospatial extension is very interestingly named DMS to decimal, stands for degrees, minutes, seconds to decimal. And you give that the coordinates as well as either W or for west and E for east, or S for south and for north. Whether I like this API or not, I don't know, but it does work. And then it tells you where exactly the coordinates are. Now, I'm not really interested in so many decimals, so I'll be removing those in later examples, but there we go. So KSP stands for Kerbal Space Program, by the way, and Jeb lives at where he lives. Now, Of course, we can do that the other way around as well, but because degrees, minutes, and seconds are three distinct values, so I can't really return it as one complex value. I could probably return it as a PHP class or something like that, but who likes classes? And so it returns, of course, PHP's evil structure called an array, and there's a few things in there. So, of course, when you then do echo, you can combine it back to it, right? Not the most interesting thing. However, now we know where he lives. Now we need to figure out how far he actually has to go. And you have interesting formulas for that. I will not be explaining the formula here, but it's called the have-assigned function, or have-assigned formula that calculates using a spherical Earth model according to great circle lines. The great circle line is the shortest distance between 2 points on the sphere, or actually it's the whole circumference, but it is used to calculate the distance along this arc around the sphere, which you do with the have-assigned function. This API, the have-assigned function, which is also part of PHP Geospatial, actually takes GeoJSON objects. So GeoJSON is like it's a description-ish on how to store like points and lines and polygons and things like that. And the reason why I use this API is because, well, you can't probably put it in a PHP class, right? You can wrap it with the coordinates and stuff like that. But that means that if you want to show it on a map somewhere, you have to convert it all the time between those classes and the GeoJSON stuff. Me working with MongoDB a lot, the geospatial stuff part of it also stores all this data in points, lines, and polygons with GeoJSON. So I thought I'll pick this because that is handy and it saves me from having to convert between stuff. Okay, have-assign is quite okay, but it uses a sphere for doing its calculations. Now, as you might know, the Earth is not actually a sphere. Kerbin is, but Earth is not. And this tells you how many meters it is between those points. But that's not very interesting. So there's something else that's called a Vincenti, or quite called a formula, because it is a better way of using, it uses actually a flattened spherical model of the Earth, which is much more appropriate for doing very long distance calculations. But it is an iterative function, so you need to do a few iterations. And if you're getting closer to the poles, then those iterations can actually take up a whole lot of time. So there's a few preconditions and when you can use the Vincenti formula. It has exactly the same API. You give it 2 GeoJSON points, and it tells you how far it is in meters. In this case, 12,000 kilometers is a bit of a long walk for him, to be fair. All right, so next slide. Okay, so yeah, I said Jebediah lives on Kerbin, not on Earth, and it's a different size. It's only 600 kilometers, right? As opposed to the Earth, which is about 10 times as large. And to do the calculations here, we cannot use Vincenti because it's a spherical Earth model and not a fictional planet model, right? So we are using have-assign here because that will be better accuracy. Now, the have-assign function doesn't actually take into account heights. So if there is, of course, a difference between sea level and on the top of mountains distance-wise, but we don't care about that so much. And yeah, the have-assigned function, so what I've done here is the third argument, you can actually specify the radius of the planet. And this, of course, doesn't make a whole lot of sense if you think about planets, but it makes a lot of sense if, for example, if you want to, instead of meters, you want to have miles as distance, right? And so you can, instead of specifying the radius of the Earth in kilometers, you use the radius of the Earth in miles. And then you get an example. But it also works in my example, so that's very handy. And we figured out that he has to walk, 1,100 kilometers. It's going to be a long walk for him. All right, so, so which direction does he have to go to, right? So the coordinates where he lives are right here on the coast, and the space center is here. And you have here the line, right, which looks like the shortest line, but it isn't actually, of course, right? Because if you look at it, this is the shortest point between those things. So even though the first one here, it looks quite similar, how do you calculate the direction he needs to walk in? Isn't actually so simple because, yeah, as I said, the line looks like this. And you see that the direction actually changes along the trip. And to do calculations with this, you figure out the direction is something that is, well, on a scale like this where you have to cross half the planet. Perhaps not very useful, but calculation directions on a slightly smaller scale. You don't really need all the important or the difficult formulas. You can use with the really simple ones. But to be accurate, why not? So the reason why I wrote this one is because I like post boxes and OpenStreetMap, so I like to find post boxes all over the place and take photos of them and put them on the map. I think my phone found one as well. And for that, I want to see on my watch, which is Pebble Watch. I can talk about it for some other time. It tells me the direction of where the post box is in. And to do that, I wrote this algorithm, which is, well, not very simple, but not very difficult either. So let's have a look at how it works. So the geospatial extension now has a function for that, and by now I mean in the last 2 weeks. And yeah, it gives you a direction based on, so north is north, and then, well, it goes in a circle. Right? So it gives you actually, it gives you the direction in degrees from -180 to +180. I don't like that, so I might change that API later to just go from 0 to 360. My example will still work because it uses +360 in the modeler, so the output is exactly the same now. But so yeah, it calculates the initial bearing, and so he knows in which direction to walk. In this case, it's 113 degrees. Now, this wasn't working when I was writing the presentation, and I often find that working on my hacky things that I sometimes have to actually fix them while writing the presentation. So I was a bit delayed with that. But let's continue a bit more. So yes, we have here this line, right? So I wanted to draw this line on the map. And annoyingly, the mapping library or JavaScript library that I use for it called Leaflet, it doesn't actually do this. It only tells you, it can only draw lines between points, and it doesn't take into account the curvature of the Earth. Because in most cases, you actually only use this mapping API for much smaller areas than planet scale. So I thought, well, if I want to draw such a line, I need to figure out points on this line so I can draw multiple lines as segments. And the first thing I did is I wrote this function in PHP, which looked something like this. PHP isn't particularly very good for doing trigonometry. It's also by far not very fast. So, of course, I've written a C implementation as well, and which also works. So basically, I can try to explain how this works, maybe. I'll give it a shot. So first of all, what it does is calculates the distance, so it knows how long the line is, and then divide it into into as many points as you wanted, which is the calling function here. But what the input here is both the coordinates as well as the fraction along the line. So it knows the distance, calculates a fraction of this distance, and then recalculates the points, the coordinates that belong to this fraction along the line. So that is what this function does. How does that, you will have to find on Wikipedia or in a maths book. I can't explain you anyway. So yes, so this is how I do that. And now, of course, I've written a C implementation of this as well, but I just wanted to show you this in PHP because, after all, this is called PHP in space and not how to call PHP functions and extensions in space, which is not nearly as interesting. All right, so let's continue. So the other thing that I like to is if I make demos out of this video, you can see a daytime launch looks a lot nicer than a nighttime launch. So I've created this function that tells me when sunset and sunrise is. I've done this about 4 or 5 years ago, and it's part of PHP, plain PHP. It's a function called date sun info. Now, PHP used to have already an API for this. I don't remember the name for what it was. Now, sunrise and sunset, I believe. But those have a very interesting API. Well, first of all, it doesn't really take care of time zones very well. And by default, it picks the coordinates for Jerusalem. Now, why that is, I do not know. But that's just how it is. So date sun info takes a Unix timestamp. And yes, this probably should accept a datetime object. And I was hoping to finish that on time for this presentation. But that didn't work. And then you have to give it I always get those wrong, a latitude-longitude pair. The annoying thing is that GeoJSON that I showed you earlier uses longitude-latitude instead of latitude-longitude. And every API in mapping libraries uses a order that you never ever know, and I get it wrong. Well, most of the time, because that's how those things work, right? It's the same thing with bounding boxes. You sometimes have north, east, southwest as coordinates. Of course, for you that is north, east, southwest. But sometimes you see north-south first and then east-west first. It's mind-boggling.
Nothing new with PHP.
But has nothing to do with PHP. No, that is absolutely true. So when you call this function, it actually doesn't give you one data point. It doesn't give you just sunrise and sunset. It gives you a few more things, actually. So it gives you sunrise and sunset in Unix timestamp, so you can calculate that to your local time by putting into a date create. But it also tells you the transit, which is the point it goes through zenith, or well, mostly south, but not always necessarily south. And it's not always directly in between the sunrise and sunset, depending on stuff. But it shows you a few other things as well. It shows you 3 different kinds of twilight. And depending, well, the name of those data points actually tells you what the difference really is, right? So yes, civil twilight, which I think it is defined as it's light enough so that you can read a book outside or something like that. And you have nautical twilight, which I think is enough. After this point, it is dark enough so that you can navigate on the stars. And the astronomical twilight is when it's so dark that, well, you can't see anything unless you have a light. And it's very good for observing astronomical events, like stuff. Maybe rocket launches or the ISS. But again, sometimes you can see those in daytime as well. Anyway, before I continue blabbering about that, let's look at some more stuff. So, yeah, so the position of the sun in the sky is something that I needed for my Raspberry Pi thing, right? I wanted to know how far the sun is over the horizon so I can approximate the color of the sky at that moment. So I use a few data points for that. I know whether it's overcast or raining or snowing or thunderstorm. So I create a darkness color based on that. And then depending on how far the sun is over the horizon, it will tell me, it fades it to the night color, which is differently defined again. So Earth-Sun pass is actually a wrong name because it doesn't calculate the position. It only calculates the height over the horizon. That's why there's an unhappy face. But actually, internally, the extension that implements the algorithm actually does calculate it. I'm just not exporting it. So again, I will change this API at some point. And actually, to just show you that it works, if I reload the slide, you can see the value actually changing. So at the moment, the sun is 22.87 degrees over the horizon. You can go measure that if you don't believe me. Okay, so I'm also working on the full position of the sun, so both height as well as azimuth. And I'm also going to do that for the moon. I actually have written that already, but not exported in the extension yet. So I'm talking about our moon, not the moon, which is Kerbin's moon. So I'm not talking about that right now. Anyway, so this is probably the stuff that we've done on land. And Jebediah finally makes it to space station. He's figured out it's light and the sun is high enough in the sky. And now we need to shoot up some rockets, because that's how that goes. That's what astronauts do, of course, or kerbonauts in this case. Okay, so there we go. So there's something called a thrust-to-weight ratio. And basically it means if it's larger than 1, you will take off. If it's not larger than 1, you will not. And I will demonstrate that by some in-game footage. All right, so when you just start, you can see the surface-to-weight ratios being less than 1, right? Because the thrust compared to the vessel's mass is not in the correct ratio. So you see that once it hit 1, the rocket lifts off. And that is how that works. So if you're designing rockets, which I'm sure all of you have done once in a while, actually I've done some model rockets, and this is very important. I mean, our competition was to shoot up the rocket as high as you can get with a standard engine. So what can you do to make that better, right? I've seen some of the other teams that were also doing this. They're making really elaborate design. What our team did, shave everything down as much as we can to make it as light as possible. Forget about safety things like some cotton wool so that the back charge of the engine when the parachute comes out actually doesn't blow up the altimeter. We managed to scorch it, I think. But to all good things, we actually managed winning because our thrust-to-weight ratio was the best, and that means with a set engine, you go the highest and you win the competition. I will not talk about what happened to the parachute, though, but basically it fused together because of engine exhaust. But anyway, so yeah, this is how this works. And you can calculate this quite easily, right? So let me go to the next slide. So yeah, so when we start off the rocket, this is readable, all the little tiny things in the back as well? I don't think you can make it much better, but I'll point them out and show you what the numbers say. So when it's just standing still with all the fuel in there, I basically created a rocket that doesn't really fly very well. So the mass is 3.5 tons. The engine thrust is 30 kilonewtons. It's a very tiny engine, the tiniest engine I could find, actually. And the maximum acceleration from that you can calculate, right? I'm not sure why this number here doesn't match the number here. It's probably because I added the landing struts at some point. And so yeah, with this you can calculate that the surface to weight ratio is 0.88. It's not enough, it won't lift off. So when I start burning my engine, what happens is of course that it gets lighter because I've been burning fuel. And a moment where the surface to weight ratio hits 1, it lifts off. Well, now, let's see how we calculate this. Also, it helps if you point the rocket the right way up, which I hadn't done the first time. All right, so yeah, to calculate a maximum weight depending on the thrust of your engine, you can calculate quite easily by dividing the thrust by the surface gravity. And Kerbin's surface gravity is exactly the same as Earth on the equator. So it doesn't have the variations that the Earth's gravity has depending on where you're close to mountains or not, because that'd be a bit too much to model in the game, I'm sure. So yeah, this is how we calculate it. It's by far not the most interesting equation because you divide by something. Finding this in detail or finding the formulas was a bit trickier. So yeah, surface to weight ratio is simple enough. So the result of this is that the maximum weight can actually be, when we have a 30 kilonewton engine, that the maximum weight was 3,058 kilograms, which, as you look here, is about what the in-game thing did as well. Right? It said 3,050, but that's more because I don't have all the decimal points, so I had to guess. So it actually models it quite well, and that's somehow didn't actually surprise me. All right, so what else are we going to look at? Well, once you're up into an orbit, you need to do orbital maneuvers to get to places, right? And the way how you calculate that is with something called delta V. Also, first time I did this rocket, you probably watched this because I promised explosions. I forgot something. I forgot basically to, you can see that on the side here. This means docking clamps. And you should not put those all the way at the end. They should go all the way in the front. Yes, I play with this game and I blow up so much stuff. In this case, however, Bill survives. So Bill's actually quite happy. Bill's never happy. He's always very grumpy and afraid of being blown up. Well, I know why. Right, so yeah, point the rocket the right way up, as well as make sure it doesn't fall apart when igniting the engines. Always good. All right, so let's talk a little bit about delta V. Delta V is something that is used in rocket equations a lot for many different things. And this is also called the Tchaikovsky rocket equation. I might get the name wrong, but it's a clever person that came up with this formula that explains the delta V, the maximum delta V a vessel can do. And delta V basically means a change in velocity. Not thinking about atmospheric drag or stuff like that. So it is in vacuum. And of course, if you're getting off a body, then like a planet, then yes, there's atmospheric drag anyway. So this equation doesn't fully work because there's a negative force. Well, you have heard of terminal velocity, I suppose, right? Something falls, and it doesn't go faster because the air pressure counterweights the. I don't know the term for this anymore. I knew all this physics stuff, but not anymore. Anyway, so this is called the rocket equation, and it basically works as follows. You have the initial mass, including the fuel that you're going to use to shoot it up in the sky with, or propellant as it is more nicely called, and we have the final total mass. And of course, that is the difference between empty tank and full tank. And
things you lost.
And things you lose when, doing stuff. I'll get back to losing stuff as well. So delta V is a difference in velocity. Ln is the logarithmic function, which in PHP isn't ln, it's called log. And then VE is the effective exhaust velocity. Basically, that tells you, well, how well is your engine actually doing. So for that term in this formula, we have to have a further look. And basically, specific impulse, what that VE stands for, is the acceleration due to the gravity at the surface. Of course, the higher up you get, gravity gets less, but that's something that I'm not talking about here either because it gets too complicated. And as I said before, this is about the same as it is on Earth, on the equator. And then LSP, or it's not LSP, it's ISP, is the specific impulse in seconds. I misspelled that, but you can't see that because in this font it looks the same. And yeah, so yeah, you use this term, and then you put it in the other function formula to calculate the maximum delta V. And of course, I have a worked out example here. So the in-game things, they're actually modeled very well. So it is not like, oh, this is a funny game that allows you to do rockets. No, it's actually very well thought out and all the physics in there, pairing some, well, things they haven't thought about yet, like re-entry heat, works actually really quite well. And all the formulas I tested whether they actually work in the game, and yeah, it even was correct. I was more surprised that my calculations were correct than the game was, to be fair. But so yes, we have those two things. And so specific impulse is the gravitational constant times the specific impulse. In the game, the ISP at sea level is being given as 300. Most engines, they have a different specific impulse depending whether in an atmosphere or not. For calculations here, I'm not thinking about that because, again, that makes it too complicated, but the game actually does model that. Wrongly, but it does model it. So the ISP at sea level is 300, and the maximum engine power is at 30 kilonewtons that you've seen before already. Also, the fuel tank, if it's full, it's 2.25 tons, and if it's empty, it's only a quarter ton. So the difference is 2 tons, which is something the function needs as well. So again, I've implemented this in PHP, and it's actually not very difficult to do because. So yeah, you multiply specific impulse. Again, this is misspelled, but in this case, you can see that because it's a different font. Times the graphic full mass and empty mass. And by running this, you get result 2439 delta V out of this, which, if you're actually up in space, this number is actually what the game shows you as well. That's quite good. That's quite a lot. To enter orbit around Kerbin, you need about 2100 meters per second. So you would think that this rocket would manage that, but it doesn't because of the atmospheres in the way as well. So that doesn't work. Anyway, so a few more things. Let's do some velocity calculations. Again, more maths. I did promise maths and explosions. So what this does is, the blue line here is the orbit of my spaceship, right? You can see what the periapsis is, the closest point to the body, and the apoapsis. So the closest point is about 300 kilometers. And I wanted to have the apoapsis as 1,000 kilometers, but my piloting skills weren't good enough. Well, you try this later if you want to see how easy this is. And yeah, you can calculate what the velocity is at either point. If you know a few things, you need to know the mass of the body you're orbiting around. And of course, technically, the mass of the vessel also has an influence on this, but comparing 3 tons against Moon doesn't really much of a difference. And at least PHP is not nearly as accurate enough to calculate that for you. So let's forget about the mass of the vessel itself. And yeah, there's a few things that you need to know about here. So you have the shortest distance, R1 or periapsis, and you have the longer axis, which is the apoapsis or R2. So here in the middle, you have the Moon, and you can see that, of course, this bit is shorter than that bit, right? So in orbital mechanics, the velocity of the spaceship is not the same all around the orbit. If it was a circular orbit, then yes, it is the same everywhere. But I'll get back to the circular orbit in a bit. Also, even though the apoapsis and periapsis say 300 and say 1,000, even though it's 998, that is not actually the radius, because you also need to take into account the radius of the Moon, and the game doesn't tell you that. So yes, this is why I'm adding the 60, because the Moon is 60, or has a radius of 60 kilometers. So how do we calculate the velocity at the R2 point, which is the point furthest away in the orbit? Anybody knows how to do that? No? It's okay. I didn't know either. So I watched some videos on YouTube and now know how this works. Anyway, there's a function for this. So a bit more maths we got here. So we have the mint candy moon here again, called Minmus. and we can calculate then with some terms what the velocity is. Of course, there's a spoiler in the bottom, which says 29.07, but there we go. So what are the terms in here? There's like some cosmic constant. Why it is a constant? I don't know. The scientists don't know, and they don't like it because they want to have this big theory that ties everything together, and they don't want constant in it. But they haven't figured it out yet, so we have a constant, which is actually not very high. It tells something about the weakness of the gravitational forces compared to other forces. Like, what are the other ones? There's 4. Okay, I can think of that if I think about it a bit more. So yes, and then the other term that we use is m. Anyone wants to guess what that is? It's the mass, or the mass, yes. And this has many digits, so in the calculations I chopped off the last bit because I got tired of typing into my calculator. And then the other term here tells you something about the relation between the velocity and the distance to the middle of the, or the major, semi-major axis. I forgot to explain it here. So there's one other thing that is important here for those calculations is basically the average between the shortest and the longest distance, which is somewhat in the middle here, which is called a semi-major axis. And you can calculate it by just using the average here. So in this case, what is it? 700 and something. Actually, 709, because it says it right here. So we calculate that, and then we also know the distance at the furthest point, because that is the same as the apoapsis, which in this case is 998 kilometers, plus the radius of the moon is 1,058 kilometers. Now, when you plug all those terms into your formula, you get 29.07. And to verify that, I plugged it in the game again, and what does it say? At the furthest point, it says 29.12. Now, there's a few things why, because I'm actually not fully at the apoapsis. I was a bit too early. To be precise, I was 9 minutes and 7 seconds too early. So the velocity hasn't reached, well, its largest number yet. But it's good enough, right? Now I also know why my calculations were wrong first, because I really thought this was 300,000 kilometers. And then you get factors wrong, of course. Anyway, so delta V is this measure that tells things about a change in velocity, right? So how do you calculate the difference between the current orbit that I have as well as the circular orbit? Is this actually circle for you? No, it isn't. No. Okay, the aspect ratio of the screen is wrong. Imagine it's a circle. Imagine it's a circle. So how do you calculate that, right? It's, well, fairly trivial. You basically calculate the velocity at any other point in the other orbit, and because it's a circular orbit, the speed is the same all along the orbit. All right, so we come back to the circle here, and we can use a better formula or a simpler formula because we only have one, or there's no difference between apoapsis and periapsis. So the formula is a bit easier, and you end up calculating that you get 40 meters a second out of this formula as a speed on a circular orbit, or around Minmus. That is made out of minty candy. All right, so what is the difference in velocity? Well, if you calculate 40 minus 29, roughly, you end up at being 11. And when you look at the game here, it says 11.8. So again, my calculations work properly. And of course, how do you get this delta V? By burning your rocket, right? So let's burn some rockets. All right, so what I wanted to do is actually simulate or talk through all of the equations of getting to Juno, which is the Mars variant in the game. So I have this big rocket here. Bill's flying with us. He's frightened as usual. And when you lift off, you see, actually, the video moves faster than I can speak because I sped it up. But you see that it's doing staging as well, right? Okay, stop, there. Okay, at some point, you see I'm not going straight up. I'm taking like a turn because it's much more efficient to do. It's much more efficient. Also, my rocket has wings, which creates some lift, which is a bit cheating, of course, but it does work. On Earth, you would do this in a totally different trajectory. In the game, you go up straight for about 10 kilometers and then start turning. As you have seen rocket launches on TV, it starts doing the turn almost immediately. Mostly because the Earth is 10 times as big, the atmosphere is a bit denser, So yeah, it works better. You have to talk to the real rocket scientists exactly why. I'm just an amateur one. And yeah, you see that after launching, you see like this orbit, and you can see, of course, that it is not actually an orbit because I'm not going fast enough. Basically, orbiting is falling slower than the planet rotates. So you just fall really, really fast in a direction. But the moment you do that, the Earth is, or the planet is lower, so you just need to fall in the correct speed so that you orbit. Right? That's basically what orbiting is. So this is why there is still gravity in orbits as well. That's one of the reasons. Anyway, we burn some more, and at some point, well, I don't have to burn for a bit. Oh, so you saw my staging there, so I have to go back there for a moment because I went too fast. Okay, so once I pop up the details there. Okay, so what you can see, oh, that's difficult to see. So I have used staging here, right? And the reason why I've used staging in a rocket is so that carrying up lots of extra things like rocket engines and wings and stuff you really don't want in space, like tiny nuclear power station that power your rockets. Yeah, you want, of course, to make it back to the planet. You want to not have that end up in space because things floating in space can cause issues. Anybody have seen Gravity here? You know, you've now heard of the Kessler syndrome. The Kessler syndrome is actually one of the loading funnies in this game. It says treating Kessler syndrome, which makes no sense whatsoever. For the people that don't know what it is, the Kessler syndrome basically says that at some point there will be so much debris in an orbit, in like low Earth orbit, and that will hit other things. And because of this, you get this exponential collection of debris in an orbit. And if this actually happens, that means we don't go to space anymore. Or we shoot it all over the sky with a big laser, which would be awesome. Next talk. Next talk is about lasers, yes. So yeah, the staging happens so that, yeah, you don't take so much weight with you. And because you drop stuff off and make sure it nicely re-enters, you get much more delta V out of it because you lose all the weight that you don't need. So this is why I'm using staging here. So I've actually, 4 stages or something like that. So the first one is with big solid rocket boosters. And this is something you should know about Kerbal Space Program. If it doesn't go up, add more boosters. Which doesn't actually work. So, and also another reason why you use staging is because you can use fuel lines between outer tanks to inner tanks, again, getting more performance out of your rockets because of weight things. So at the moment, I'm still having 2 of my side boosters on here, which you can see in this stage, and you can see that the thrust-to-weight ratio is actually 0.40, which is by far not high enough. Sorry, at the current state, it's 2.20. But when I lose those rockets, the thrust-to-weight ratio drops to 0.40. And as you might remember from previous slides, that is not enough to get up into space. But we're already going almost to the orbit we want, so it sort of works. I mean, actually, I probably should show you that, what happens. So when I lose them, the thrust-to ratio is now 0.40. And you can, okay, once it pops up, you can see now that my orbital speed is 1905, and it needs to be about 2150. Probably should use the slide as a calculation for that one as well, which I could have done. And it says that the apoapsis is at the moment 80 kilometers. I wanted to create an orbit that was 80 kilometers around the planet. And you can see the periapsis is minus 238. That means that you will crash unless you add more delta V to your rocket. And it tells you the time to apoapsis is 37. And what you try to usually is get to apoapsis up to a minute, which is a safe enough margin. So you actually see that when I burn here now further, the time to apoapsis drops because I'm not actually having enough thrust-to-weight ratio. And then you see it going to 30 minutes, and then I make it again. And then you see it orbits. Okay, so orbits here again. From this orbit, I need to go to a different planet. And this is also a calculation that I know how to do, but I couldn't get to work, so I don't have it on a slide, because that would look silly. I'm not sure why I'm telling you this, but there you go. So yes, we have this orbit, and there's a way to calculate the correct ejection angle of the planet that you're orbiting on, doing that at the exactly right moment to have an optimal trajectory to your other planet. This is called launch windows, makes sense, right? And you don't have to wait for launch windows normally because you can just add more power to it, but it's so much more efficient to do. So this is why you hear on the news like, oh, they have to wait another, well, it's for Mars, it's like 18 months or something like that. So you don't really want to miss your launch window. So yes, that is, in the game, there are some calculations for this, and I actually wanted to see whether I could do that myself, but I failed. So I just show you how it looks like instead. So yeah, you have to wait until, at the moment, I have to wait 14 minutes to my launch window. And you can see what I've done with the orbit here. I've set it up earlier. So it is like this perfect trajectory to hit, in this case, Juno or Mars. You can, however, see that there's like tiny triangles, and the tiny triangles make say this is the closest approach. But it means I'm not actually getting captured by the planet's gravitation. And that is because the orbits are not in the same plane. There's a slight inclination, which I'll get to in a moment. Blah, blah, blah. So, okay, so here you see that the descending node is 0.1 degrees, which is just enough to miss a planet. So getting those numbers right is quite important, which you probably shouldn't bring up with a party with some British scientists that managed to miscalculate this with a thing they actually sent to Mars. And then ended up missing it because they didn't know the difference between inches and centimeters. But that's another interesting story. Anyway, so yeah, of course you need to make this course correction. And course correction is something that NASA does all the time as well because they have to. I mean, they're quite good calculating stuff, but if it's only a fraction of a second off sometimes, which happens with rockets all the time because it's just not exact science, yeah, they have to make course corrections. So in this case, I have to burn, so it did tell me. It's about 1,100 meters per second, delta V. And of course, my rocket has way more because I over-designed stuff. So yeah, it burns a little bit, and you can see the orbit now getting larger, right? And it gets up to a point where it will snap out. Because this is the point where the orbit goes out of the sphere of influence. And the sphere of influence is something that doesn't really exist in the real world, where gravity is always going to have any influence on it. However, modeling gravity in the solar system, where you have so many different bodies of different masses, is so complicated that you can't actually do it with more than 3 bodies in the system. So this is why people need to make course corrections, because you just can't calculate it. And in Kerbal Space Program, this is not a problem because it only does 1-body physics, or well, sorry, 2-body physics. And it has this concept of sphere of influence. So the sphere of influence reaches to a certain radius, and then it switches to a different body, in this case, the sun that you have here. So we're making some course corrections here. There we go. So my rocket is a bit wobbly because I don't know how to make rockets. And it's also very handy that you can speed up time. That means that I don't have to wait 200 days to actually get somewhere, but I can do that over, well, getting some coffee, I suppose. So depending on the rocket engines, they don't always have the same specific impulse. So the engines that are really efficient don't have a lot of thrust. So in this game, there is a, hang on for a second. There is an engine called an ion engine, which actually exists, which are really efficient, but they generate so little thrust that in-game, it takes me 23 hours to get to the delta V that I needed to do. And annoyingly, if you have a throttled-up engine, you can't time accelerate. So yes, you have to wait the 23 hours, or add more boosters. So in any case, we have arrived at the planet here, and landing is the most tricky bit, and I'm not very good at. But yeah, so we come in about 1,500 meters a second. Slowing down, I will not have enough fuel for anymore. But what I do have is an atmosphere. So the general concept is that you use the atmosphere for braking. Now, the game also can calculate that for you, but I can't because I haven't found the equations yet. But we'll see what happens here. Again, this is time accelerated in the game, but also the video is sped up 4 times. And you can see the orbit getting smaller and me not adding any fuel to it because I'm using the atmosphere for braking. And once it's done, it gets somewhere. Okay, it takes another minute. I don't want to wait for that. So I miscalculated, so I need to burn anyway. And at some point, you can see my landing spot, right? My landing spot says here. Okay, it gets there. I don't want to overdo. So landing gear comes out. I use some more fuel because I don't want to pollute the planet. Ditch my stage. Open the parachute and aim. So I aim very nicely. See the other thing. My parachute comes out. It crashes, that one here. And then I land, but it falls over. So I just spent an hour doing this, and then you fall over, which is really annoying. And you know about what I said about pointing the rocket the right way up, otherwise it doesn't go into space. He can't go home anymore, which is really annoying. All right, so what I still have to do, probably for maybe a future version of the talk or implement in a few other extensions, I want to continue working on the solar extension. Do the correct position of the sun and the moon. And for the moon, you can calculate two types of positions. You can do the geocentric, basically from the center of the Earth, or topographic, is where you are on the Earth. Also makes difference, of course, to where the moon appears in the sky. So I want to do some calculations for that. Those calculations are really difficult. I found a really good website for this, but I don't understand it yet. So I have to do some more learning. And the same thing, I want to do the same thing for planets, which I can't really see much use for in PHP. Sun and moon, yes, I probably can find other interesting uses for. And I want to do some more spacey stuff. So there's some other things that I want to have calculations for as well. There's something called the Orbit effect. It basically means if you go faster, your engines are going to be more efficient in creating delta V. Aero braking is something I want to calculate. The Hoffman transfer, which is the most optimal transfer between two orbiting bodies. And when I was researching that, I found something about bi-elliptic transfers, which instead of making one good burn, you actually create a burn that goes way too far, and then use another burn to align your orbit with what you actually want it to be, and that can be more efficient. And there's actually, I figured out that they use that for putting geostationary satellites into orbit. That's how they do that. I didn't know that. Because, yeah, usually the rockets that send stuff up into space, they have more power than they actually need, so they use that to reduce the amount of fuel that the satellites need to get into the correct orbit. So that makes a lot of sense. And yes, I want to put all the equations that I use in this presentation into an extension or one of the ones I already have. And of course, I need to rescue Bill because he's stuck at Juna. So my first attempt was something like this. I think, let's just throttle up the engine, and that didn't work particularly well, and he died. That's why you have save games, which you can't do in real life. Anyway, any questions? Ooh, I walk into something. No questions. Who's going to try out Kerbal Space Program later today?
It's going to happen.
Sorry. Yes.
So how long did it take you from scratch to get to your level of expertise in this game?
What unit would you like this in?
Beers.
In beers. Okay, in beers, it is approximately 200. I drink about a beer an hour, so there you go. No, that takes quite a lot of time, but it's lots of fun. And of course, I'm actually better than I'm showing here, because I promise explosions. All right, anything else? I had a question for you, but I didn't see anybody answering, because I got distracted. Who's going to try out Kerbal Space Program later? If you need help, let me know. I've helped many people getting into orbit, which is step number 1. Landing on moons is step number 2. Docking in orbit. Yeah, that is a pain. Yes, question right here. There, you have a microphone there.
So when you get to the planet, what do you do then? Just go back?
Oh, no, well, that's the plan. No, actually, the idea is that you collect science everywhere, and science allows you to unlock more parts. However, that has nothing to do with PHP. I actually looked at using PHP for creating extensions to the game. because it's quite open, and there's lots of people that create modifications for it. However, this has to be done in C#, which means I would have to write an interface between C# and PHP as well, and that is going a bit too far for my limited amount of spare time that I already have. All right, you had a question as well? You can also ask questions about the PHP bits of the talk.
Is there any physics in the game that you actually found disappointing?
Physics that I found disappointing, yeah, re-entry. Re-entry, it has effects, but you don't die if you do it wrong. So that is something I miss. But there's mods for that. Also, the parachutes aren't really quite good, or it's not very well modeled and things like that. So yeah, there's a few things. But it's an alpha version of the game, and I'm sure it will be all modeled in the future. Having a different solar system that you can go to with a warp drive, maybe. You never know. But I won't go into the physics of that one.
You mentioned launch windows.
Yes.
I had a quite long argument with my friend on this game about if it's better to plan your launch from scratch, from Earth, or whether you do it once you've reached a steady orbit of, say, 80K.
I do it from orbit. I think it works better. It's definitely easier because you can create a safe game in orbit.
I've seen that it's actually Unity that the platform the game is running in.
Yeah, it's Unity.
How accessible is it for people who are not on the alpha program? Is it still available to buy on Steam, or how does it work?
I don't know. I really don't know. I haven't looked at that, but I would like to know at some point.
It's on Steam, available to purchase now.
Oh, yeah, the game is on Steam. Sorry, yes. Yes. All right. Anything else? Well, I hope this was somewhat useful, at least entertaining. I have no more questions, although I have 9 more minutes. So if there's anything, do you think that some of the calculations, besides the spacey, rockety stuff, because no real rocket engineer is going to do them in PHP, of course, but things we were to calculate positions of the moons, do you have any ideas what else that could be useful for?
Soon-to-arrive flying cars that we'll all be driving. I'm
yes,
sure we'll need
flying
some
cars
kind of open source available
that were
mapping system.
promised to us 40 years ago. Yes.
It could be used to control an automatically pointing telescope. They already exist.
Yes.
So if you have a system that can calculate the position of a planet, the moon, you can automatically point telescopes at it.
Yeah.
That does exist, but not a PHP version, I don't think.
No, I don't think so. But, very good. This one in the back.
I've got a question.
Okay.
Putting the moon on a map on a mobile device could help you orientate it. So
that's very true, yes. That is true as well, yes. All right. Okay, my first attempt is not going to be my last attempt. My most epic failure was not going to the Mars variant, but going to one of the moons of the Jupiter variant. Very nicely landed. I had a proper rocket, but I broke off the engine upon landing. So he's stranded there, right? And I spent the whole Christmas holidays designing a bigger spaceship to land, pick him up, and fly back. And I will actually create a video out of that at some point. I don't like it. Anyway, yeah, thank you very much. I hope you enjoyed this, and there will be more talks.
Yeah, Derick, thank you very much.